This is Abhishek Mehrotra from Classes-kanpur, and in this video session we'll know about conservation of momentum. So before starting conservation of momentum, let us discuss about what momentum is. A question arises, what is a momentum? So momentum is represented by a symbol P, and what momentum is? Momentum is simply the product of mass and velocity. Mass into velocity. This is exactly what you need to know. Momentum is equals to mass into velocity. Okay. If suppose you are 50 kgs and you are running with a speed of 20 meters per second. So what is your momentum? It would be the product of your mass and your velocity. So when you will put these values of mass and velocity and multiply each other, you will get the value of momentum. Okay. And what is its unit? So momentum की जो unit होती है, that would be equal to the unit of mass, which is in kgs, and unit of velocity, which is meter per second. So this is kg meter per second. This is what it is, the unit of momentum. Got the point? Okay, we have already learnt that we know about two velocities. One is initial velocity, which is represented by u. This is what initial velocity. U is initial velocity. And other one is v. V is what? Final velocity. Final velocity. Okay. So velocity can be either initial velocity or final velocity. So when you are using initial velocity over here, then momentum becomes mass into initial velocity. Since velocity is initial over here, we are using initial velocity over here, then the momentum becomes initial momentum. Initial momentum. Alright. And if you are using final velocity v and then multiplying with m, due to this final velocity, the momentum becomes final momentum. Okay. So since we know that velocity, there is a change in the velocity. We know that there is a change in the velocity. What is change in the velocity? If suppose you are moving, you have just started a motion with 20 meter per second or 20 kilometer per hour, and after a few minutes or a few hours, you changed your speed to 60. Then the change in the velocity would become final velocity minus initial velocity. So change in velocity would be final velocity v minus initial velocity u. So since your final velocity was 60 km per hour and your initial velocity was 20 km per hour, then change in velocity would be 60 minus 20, that is equals to 40 km per hour. You got the point? This is the change in velocity. Similarly, change in momentum is what? From both these equations, change in momentum. This would be equals to what? Change in momentum becomes final momentum minus initial momentum. This would be final momentum minus initial momentum. Final minus initial. So change in momentum, what is change? How change is represented in physics? So you can represent a change by just by this sign, delta p. Since p is the momentum, this is what? P is the momentum and delta before P means change in momentum. So change in momentum can be represented by delta P, which is equals to final momentum minus initial momentum. That means mv minus mu. This would be the change in momentum. Got the point? Okay. Now, so now comes the law of conservation of momentum. Law of conservation of momentum is one of the most prominent laws in physics which we need to learn. So the conservation of momentum law of principle, this tells us that total momentum of the system is always conserved. That means if suppose we have taken an isolated system in which energy is neither getting out of the system or nor it's coming from within the system, so that would be an isolated system. So that conservation of momentum means there would be no loss in the momentum, it would remain same. Okay, so what conservation principle is, for two or more bodies in an isolated system which are acting upon each other, the total momentum would remains constant. So this you need to know, the total momentum remains constant. Conservation of momentum says what does it says? It say the momentum can neither created nor destroyed. This is the conservation of momentum means. Okay, it would never be changed unless and until you are applying force. If you are applying some external force, only then it would change. So since the application of force is important, we need to know how a force affects the momentum. Okay, now as we know that force is what? Force is the product of mass and acceleration. F equals to m into a. And what a is? A is the change in velocity per unit time taken, v minus u upon t. This is the definition of acceleration. Acceleration means change in velocity per unit time taken. If you are moving with a velocity 20 meter per second or 20 kilometer per hour, and your final velocity becomes 60 kilometer per hour, that means change in your velocity would be 60 minus 20, which is 40 kilometer per hour. And if suppose you've taken 1 hour to change your velocity from 20 to 60, so putting t equals to 1 hour, and delta v would be 60 minus 20, which is 40. So acceleration would be 40, and the unit is kilometer per hour square or meter per second square. Okay, so putting this value of a in this, when multiplied by m, then you would get the final force. Okay, so here comes the story. When you are applying a conservation of momentum principle, so for this reason you have to consider two colliding particles. Two colliding particles means, let us suppose you have an object A and this is object B. Let us suppose you have two balls, one is A and the other one is B, and both these objects are brought closer to each other by the application of force. They would tend to change their momentum principle. Okay, how? So let us suppose this object A has an initial velocity u1, and after a few minutes its velocity changes to v1. Similarly, this object B or ball B has initial velocity u2, and after a few minutes or few interval of time, it changes its velocity to v2. Both these balls are moving towards each other. It seems that after a few minutes they would collide. Okay, so in this case, conservation of momentum principle takes place. Okay, so for body A, this is body A. So for body A, you need to know what is the change in momentum of particle. So since the velocity is u1 and final velocity is v1, then change in velocity would be v1 minus u1. This would be the change in velocity. Similarly, what is the change in velocity b? That would be v2 minus u2. This is the change in velocity of particle of ball b. Okay, so what would be the momentum of particle A? Momentum is the change in velocity of body A into mass. So let the masses are identical, and okay, don't let the masses be identical. Let the mass of body A is m1 and that of body B is m2. Okay, got the point. Now momentum would be when multiplied masses m1 along with change in velocity of body A, and similarly mass m2 is when multiplied b with change in velocity of body B. So this is what the change in momentum of particle A, and this is the change in momentum of particle B. Here let me write it down. Change in momentum of a particle, a body, and this is the change in momentum body B. Okay, so this is what, when these bodies would collide to each other, their forces would be FA to B, and this is FB to A. Okay, this is moving with magnitude opposite to this one, FAB. So we can say FAB equals to minus F of BA, and vice versa. F of BA equals to minus of FAB. We can write this either F of BA equals to minus of FAB. What minus sign indicates? Minus sign indicates that the direction is opposite. Okay, so we know that FAB is what? FAB is what? This is equals to mass into change in velocity upon time. So we can write F of AB as m1 into v1 minus u1 upon time t1, and F of BA is what? m2 mass into change in velocity, that would be v2 minus u2 upon t. Why we have taken same time over here? Because when a body moves from A to B, or this B to A, it would have common time t. Let that time interval be t. Okay, so that shows in t time both the bodies would collide with each other. Now we know that F of AB equals to minus of F of BA. We can apply a minus sign over here. Okay, now we can clearly see t is easily gets cancelled out. So this would be m1 into v1 minus u1, which is equals to minus m2 into v2 minus u2. In the next line we can write it down, m1 v1 minus m1 u1 equals to minus m2 into v2, minus minus would become plus m2 into u2. Okay, now take this minus, take this minus over here, and this minus m2 v2 over here, we would get a new value which is equals to m1 v1 plus m2 v2, m1 v1 plus m2 v2 equals to m1 u1 plus m2 u2. Got the point? So this is what, this is the equation which shows the conservation of momentum. You have to write it down, mark it and write it. So this is the equation of conservation of law of conservation of momentum, where m1 u1 plus m2 u2 is what? This is the representation of total momentum of particle A and B before collision. m1 u1, since these are velocities u1 and u2, so this side would become before collision, before collision, and since there are final velocities and final velocities are generated only after collision, so this side would become after collision. So you can easily see before collision and after collision are equal. Since the states are equal, so we can say that momentum is conserved. So what are the examples which you can have in conservation of momentum? So when you have air filled balloons, this is what an example of conservation of momentum. Motion of rockets also do have the conservation principle. And when you have a system of guns and bullets, that means when you fire a bullet from a gun, you would have an equal impact on your shoulders. So these are some examples which states the conservation of momentum. I hope you like the video. Please go through it, and in the next video we'll get to know about the numericals based on this conservation of momentum. So thank you, keep watching, and please subscribe us.